Many people fear the end is nigh, but often disagree on which end that is and why, which is understandable since there are so many to choose from. And who knows, we might not need to pick just one. When it comes to disasters, you often get a bulk discount. So welcome back to another Sci-Fi Sunday here on SFIA, where we focus on topics out of science fiction and try to discuss how real or unreal they are, and what our modern knowledge of science tells about them, including what it suggests as alternative approaches. It is hard to say what the most common sci-fi tropes are, since they change over time as new science fiction is written with new ideas and concepts. But right now anyway, they do include staples like evil twins, time travel, robots, aliens, and many more, with one of the big ones being trying to avert an apocalypse or surviving after one. And that's the reason for today's title, Surviving an Apocalypse as opposed to The Apocalypse, as we will be looking at a number of civilization-ending scenarios today, and asking what the aftermath might look like and how to repair things afterwards. We'll aim for optimism but also realism. After all, there is a light at the end of every tunnel, it's just sometimes it's an oncoming freight train. We will mention in passing any obvious way to avert a given apocalypse, but today our optimistic focus is less on how to avert disaster than discussing what we could do afterward to rebuild, and how severe that disaster would really be. After our first topic, we'll be moving through the other topics fairly quickly today, and covering nuclear war, asteroid strikes, a supernova or gamma ray burst hitting Earth, massive climate shift, a BioWar, the concept of a zombie apocalypse, artificial intelligence, and an alien invasion. Now, a lot depends on things we don't necessarily know, which is possibly appropriate as the word apocalypse comes from the Greek for uncover or reveal, and is popularized as a doomsday scenario by the last book of the New Testament, the Apocalypse of John, also known as the Book of Revelations. In that scenario, the end is implied to be rather supernatural, and that would be a great example of unknown unknowns, black swans, or out-of-context problems, or OCPs, the sort of totally out of nowhere unexpected shift that no one is really expecting. In this case, while we often talk of the end of the world, I don't think most folks are really expecting an army of angels or demons to erupt onto Earth. We wouldn't really know what to do other than pray, but at least in that scenario, you can't assume that is a valid option. It's probably a valid approach in any other supernatural scenario like that too, such as if mountains suddenly turn out to be sleeping giants, or Cthulhu emerges from the deeps. Also, in cases like this, survival might be a worse option, or you might not want to avert the apocalypse, and in cases like the literal apocalypse, averting or mitigating it isn't really in your realm of control. On the flip side, things like nuclear war, artificial intelligence going haywire, or man-made climate change are obviously in the realm of human control and avoidance, and should best be avoided, while a sudden super-strong volcanic eruption blackening the skies worldwide is really more about mitigating the fallout and getting civilization back on its feet. Same for supernovae, gamma ray bursts, or even asteroid impacts. We may one day get the technology to prevent these events hurting us, but that's not something we're prepared for tomorrow, while any of those options could happen tomorrow. Of course, so could a nuclear war, and let's begin there. Nuclear war has been on the table since the 1950s and was feared even before mass production of ICBMs, but that definitely colored the flavor of that apocalypse. Before that, the assumption was the nukes would come on bombers you could shoot down, or individual bombs snuck into ports on ships, or even a particularly terrifying version of trench warfare. Super-fast missiles dropping from the sky from the other side of the planet came to dominate the way we looked at that possible event, and you could do nothing against those except maybe strike first, which wouldn't be your personal decision anyway. The event shifts to feeling outside your control. Ironically, the scenario for ICBMs raining total annihilation down from a clear sky was never particularly probable or ruinous. You'll hear folks say we had enough bombs to kill everyone or destroy the world 10 times over, but that was just hyperbole. There was no scenario during the Cold War where everyone could be killed by the bombs unless everyone agreed to gather in all the major cities and preferably stand outside. A megaton nuclear device, which is much larger than most of those built, has a kill radius of about 5 miles or 8 kilometers, which is 80 square miles or 200 square kilometers of area. That's a fairly loose number, and kill radiuses for explosives usually assume a person standing in the open, not under any real protection, and what's more, merely are where death is reasonably plausible, not guaranteed or even likely. I was once inside the radius of one of my unit's own artillery shells during a training accident one time, and in the open, and other than getting showered with dust, pebbles, and a massive ringing in my ears, I was fine. Another time in Iraq, I had paused behind a barrier on base to shield myself from the wind while I lit a cigarette, and I almost swallowed the thing when a rocket hit a moment later, and 2 of my buddies got Purple Hearts that day, though thankfully weren't badly injured. I had quite a few friends during the war who were very much inside the radius of explosives, but had their armor on or just didn't get fatally hit by shrapnel. Of course, some did. A concrete wall is going to protect you quite well against an explosion too, conventional or atomic, at a much closer distance than standing in the open would. So kill radius, besides not being very well defined anyway, is essentially the zone in which it or severe injury is likely. And while 80 square miles or 200 square kilometers might sound like a lot, and is in terms of a dense city, it would take 50,000 such explosions to actually hit all the land area of just the United States, and peak Soviet stockpiles are estimated around 660 to 800 megatons total, around 1 to 2% of the total needed. And again, there's going to be survivors even inside that radius, especially with any advance notice. It would be surprising if even a majority of people, equipment, and stored goods in the blast zone were destroyed. Rather, the usual apocalypse associated with a nuclear war is fear of fallout, and there's a lot of debate over how potent that would really be, but it's usually felt estimates from back in the 20th century were wildly high, and the commonly reported figures were on the high and exaggerated side of those already high estimates. The simple answer is that no one actually knows. Our models are pretty theoretical, especially when it comes to secondary effects like wildfires or panicked mob activity. Nonetheless, there's not really a plausible Cold War scenario that results in endless barren wastelands populated by scattered surviving humans and mutants fighting for the remaining food. In practice, your farmland isn't really hit that hard, and only temporarily, but your supply, storage, and distribution networks are all mashed up after something like that. And extended and heavy fallout, which is getting combined with ash from burning cities and forests, is not doing wonders for crop production to be sure, but your real production issue is getting fertilizer to your fields or diesel and spare parts to your harvesters. Rather, there's a temporary collapse because you lost a lot of your cities, many of your people, and lots of your centralized control. That's the main reason why contingency shelters for a nation's leaders are important. It is not that we need a bunch of leaders in a world without any people, it's that they are priority targets by the enemy, and the vast supermajority of people would survive just fine, and a power vacuum, especially one that blows up state and province capitals too, is not a great situation to have during a catastrophe. Some might disagree, but the usual assumption is that the only thing worse than a bad leader in a crisis is no leader at all. So you aim to preserve the ones you had. That's no safeguard, and realistically you are going to have a massive power shift after an event like that. For a simple example, most countries, now and historically, are stratified politically by city versus rural populaces. So much as plagues or fires often devastated capitals or towns serving as local power hubs, nuclear bombs can erase cities and will leave the buildings which are left over heavily damaged, which will only be exacerbated by evacuations of people who did survive or left before the strike. I do not think you would have an easy time finding folks willing to move back into a city which had been that damaged and which was left to decay for a while, in which radioactive isotopes are settling into nooks and crannies of steel and concrete buildings rather than some easily plowed over field or wooden A-frame house. And that is going to move your political access right away if there's a disproportionate death toll, but isn't likely to move the folks currently in power themselves, and they could either be looking for scapegoats for the doom which befell, or be turned into scapegoats themselves, rightly or wrongly, by political rivals or changing demographics, short and long term. Those changing demographics can have some weird secondary effects too. For instance, in a lot of crises, you're going to see a higher casualty rates among your elderly population and a sharp decline in services for them or others with chronic ailments like diabetes, for instance. Stuff like that can have a horrible toll on your institutional knowledge, and all sorts of secondaries like losing exports or losing the role grandparents often serve in childcare. Same if you remember all the crazy supply chain failures of the COVID times and things people didn't really expect, like an absence of toilet paper or kids not being in school, then with any widespread disaster, those are going to be worse. And nuclear war, much like plagues, carries an aftermath fear of infection or irradiation that something like a hurricane or earthquake don't leave behind, combined with secondary effects you do see in those natural disasters, like looting, power vacuums, unrest, predatory behavior, hoarding, and so on. Essentially, this is potentially a civilization-ruining event, though depending on specifics, it might see a nation toppled and replaced with entirely new borders and factions, or it might be viewed as an extended rough patch, like the Great Depression or Dust Bowl War. There's also not enough actual radioactive material to be leaving giant swaths of radiated barren land behind either. You could literally plow your fields like normal and keep on growing. The question isn't if civilization is coming to an end, but rather the degree of continuity to it, and how long and bad that post-apocalyptic period lasts, and it's very hard to imagine that lasting even one normal human lifetime. Personally, I'd reasonably expect some degree of normality to be restored inside a year or two, though it's a new normal of course, just not one featuring endless radioactive deserts and mutant cannibals. At the moment, the stockpiles of nukes are considerably lower than during the Cold War, so this isn't really a world ender, and we spent more time on it than we will the others. Though it probably merits the time, both because nuclear war is a very realistic scenario, and because many of the other scenarios will share similar problems and collapse cases. Asteroids are another matter, as they can definitely be world-ending, it all depends on size. I mentioned in discussing nuclear war that peak Cold War armaments were in the hundreds of megatons, and pointed out that it really isn't that much at the planetary scale, and asteroids are an example of something that could very well be. An asteroid 100 meters in radius hitting Earth would release more explosive power than the combined peak Cold War arsenal. We don't have to ask what such an impact would be like. They are moderately common, and we have been hit by considerably bigger ones. Unless the asteroid's diameter is at least 10 kilometers though, I don't think we need to be contemplating any plausible end to humanity. Indeed, we would likely survive what took out the dinosaurs, and that was 10 to 15 kilometers across. Survival is a bit iffy, and it depends on where you are. Folks in the other hemisphere of the planet wouldn't really feel initial impact till the dust and ash circulate around to darken the sky. On the flip side, most asteroids crash into the ocean. There's much more of it, and there's no real dust and fallout and fires from that. But the tsunami hitting the coast is going to be terrifying, or moderately annoying. Again, it depends entirely on how big the rock is, and how sturdy your coastal buildings are. We think we got hit by one large enough to rip the whole planetary crust off way back, and that's where the moon came from. You're not surviving that, except by having a colony on another planet. On the other hand, an asteroid a kilometer across, slamming into the deep ocean, carrying 1,000 times the energy of our Cold War arsenals, is not going to have planet-wide effects if it hits the sea, not directly anyway. If New York or London or Tokyo disappears under a tidal wave, you are definitely not going to have your stock markets rising, except possibly literally if they're physically floating out on the tide. I don't think an asteroid that big could sneak up on us with no warning, but anything out past the moon is not guaranteed to be spotted, even if it is mountain-sized. Once it's in that range, if it's moving 40 kilometers per second toward us, for instance, we have about 10,000 seconds or 3 hours to cope with that, and that is enough time to get a decent estimate for the impact site and to release a plan. You also probably have at least an hour after the impact before the wave hits most places, as they generally move at passenger jet speeds. There are ways to survive a tsunami, or at least improve your odds, and the best of course is just to get inland. Tsunamis do not crash across entire continents, though a big enough asteroid impact might exceed the normal limit of about 10 miles, nor do they simply knock over steel and concrete buildings with ease. The water is going to flow back out to the ocean fairly quickly, in less than a day, but unless you're pretty confident about your bunker being waterproof, it's better to get to higher ground, especially as the possible flow of water is going to drag objects or mud over your entrance and bury you. It is always a good idea to have a way to dig yourself out of a bunker before you run out of air or drown too, though in point of fact, you're not really running out of air so much as getting choked up on too much exhaled carbon dioxide. In a case like this, rebuilding is similar to what we do after a hurricane, but perhaps a bit wider scale. Asteroid impacts are too variable in size and result to speak of a grand plan for afterward, because if we see a 100-mile wide rock headed our way a few months out, that is a case of hoping to knock it off course with some nukes, and otherwise just hoping some scattered and nuclear-powered megabunkers might leave enough humans and other critters alive to repopulate afterwards. You would almost certainly have advance warning on something like that too. The good news is that the odds of an asteroid a mile wider or bigger hitting us in a given century is much less than 1%, and nothing smaller than that plausibly exposes civilization to much risk of a real collapse, even temporarily. Bigger ones are even rarer, and in another century we will probably have the space assets to be able to spot and track every asteroid of that size in the solar system, and to deliver as much explosives as we need to move it off course. We also likely would have off-world colonies to survive us. Supernovae and gamma ray bursts are another story, as the damage they do to us is coming in at the speed of light. It explodes and we don't see it till the shockwave hits us, and everything else in the solar system. Now the good news is that any star big enough to go supernova is incredibly easy to spot, and we know every star close enough to do that, kind of. There are two major types of supernovae. One is where big bright stars die of old age, and again those are easy to spot, even with the naked eye. The other is where a white dwarf, which are quite dim normally, absorbs enough mass off a binary neighbor to explode, and white dwarfs are way more common than big stars too, as are close binaries where one is absorbing matter from the other. So too, it need not be another star, which are pretty visible. A dim gas giant or brown dwarf might fall into a white dwarf and set it off. Nowadays we can reliably spot any white dwarfs near us too, and are getting good at finding bigger exoplanets and brown dwarfs. There are 6 white dwarfs within 20 light-years of Earth, close enough to hurt us if they explode, and 4 are binaries: Sirius B, Procyon B, 40 Eridani B, and Stein 2051b. They're all B because they are dimmer than the other star. Sirius A and B orbit each other at between 8 and 32 times the distance Earth is from the Sun, not close enough for major and unexpected mass exchanges, and the other's not likely to explode either. Stein 2051b, for instance, is a red dwarf and white dwarf binary system 18 light-years away whose combined mass is too low to cause a supernova. We usually focus on supernova within about 30 light-years of Earth as truly dangerous, and this is an atmosphere or ozone layer wrecking scenario, not a planet exploding one. But even one several hundred light-years away could impact us noticeably, and there are 6 supernova candidates in that range. In terms of big stars, plus plenty of white dwarfs. Stars do move over time, and it is likely Earth has been hit by supernovae at various intensities many times in the past, and we do estimate one explodes within about 10 light-years every quarter of a billion years or so, or once a galactic year. Obviously life survived that, and deep sea life would probably survive even if you ripped our entire atmosphere off, though removing that much nitrogen might be devastating in the long term, whereas taking our atmosphere off would just boil water out into that vacuum, resulting in a period of high hydrogen and oxygen concentrations in the air. It might convert us temporarily into a Hycean planet, see that episode for details. There is a defense against supernovae, several actually, but the easier one is that you put a big thin piece of metal foil about Earth size between us and the candidate star. That's neither easy to manufacture nor keep static, but it is doable, and probably viable sometime this millennia, whereas there are no plausible supernova threats inside that timeline, except the fairly distant weak ones that we don't expect to cause major harm. Gamma ray bursts, or GRBs, are trickier, as first, they can come in a cone shape off the poles of the star that generated them, meaning they hit a narrow area rather than a spherical blast zone, and thus are dangerous a lot further away. Second, we don't actually know all their sources. Most that we observe are billions of light-years away, and no threat to us, but they usually blow out enough energy in a few seconds to equal what our Sun will in its entire 10 billion year lifespan. They can range hugely in power output though, and possible sources include very powerful supernova, quasars, Seafort galaxies, neutron star mergers, and many other candidates. Since we don't know what all the sources are, and many of the options are hard-to-see objects, and they have much wider potential range of lethality, we can't really say if we're in the threat zone for one, nor could we employ the shear technique I mentioned for supernovae, though you could arrange for an array of very high-orbit shields all around the planet except where the Sun was, and indeed future wars might employ this technique to protect against weapons like Nyko Dyson beams or relativistic kill missiles. If one did hit us, it would be basically ozone layer damage, and if sufficient, would result in mass extinction and lots of humans getting cancer, even if we were pretty good about putting on sunblock and staying inside or under shade. Many plants just couldn't survive that big a jump in the ultraviolet B spectrum radiation hitting them, and they can't hide their leaves from the sun, of course. If it were bad enough, we could see all or most land-based life sterilized, and a century or two before the ozone layer recovered enough for marine or cave-dwelling life to make a reappearance on the ground under the sun. For an individual looking to survive that, first, it won't be an instant thing, and second, we could take to the oceans for fishing and farming. I think you could also get away using shade cloth or UV-absorbent transparent plastics to keep some farming and gardening going. But this one, while probably not a threat of extinction to humanity, is definitely an option that would have a good chance of wrecking the whole planet, and depending on intensity, maybe mass extinction and a recovery in a few years or decades, or for more extreme versions, millions of years for the remnant to restore and diverge to the point of having truly diverse land-based ecosystems again. Some scientists have suggested that a gamma-ray burst was the cause of the late Ordovician mass extinction event 443 million years ago that killed over half of marine genera and took as much as 10 million years to recover from. In a case like this, off-world colonies on Mars or the Moon might recover faster, being already self-contained dome habitats with an industry and culture built around that. And our technology could be a big help to recovery. We can't keep DNA samples or create preserves to prevent various life forms from going extinct. I cannot see collecting DNA samples really happening at this point after the Cataclysm, since it's not just about acquiring them, it's about preserving them until you can use them, and ensuring that you have the means to do so if and when the time comes. I can definitely imagine lots of raft cities with big sea farms like we contemplate in our seasteading and colonizing the ocean episodes, but only a fairly narrow and improbable range of events would be likely to cause just the right amount of ecosphere damage for that future. Massive climate shifts, whether we're talking something natural or artificial, are also an example of where we might see a lot of geoengineering projects or simply ocean colonization, like artificial islands, which might be piles of dirt near the coast or floating island ships. The key thing about these is that anything that really shifts our temperature for multiple years can cause a large dip or rise in ocean level. Now, this gets exaggerated wildly in fiction. Most of the planet's surface area is too high to be submerged if the ice caps completely melted, not just a few rare mountains, but a lot of that area is not where people live or particularly want to live either, and a high tundra plateau somewhere doesn't just become magically livable and promising just because it gets a little warmer and the seas rise. Eventually, yes, but many decades at least if left up to nature. And expediting that is possible, but one does doubt the eco-engineering skill of any civilization that got themselves in this predicament to begin with. Our own climatic effect isn't an overnight sort of thing, but an asteroid or some megavolcano under the caps could definitely produce a rapid and drastic effect, and one we'd have problems mitigating since it would be a two-pronged catastrophe, climatic shift combined with an asteroid or volcano. These are not the sort of things that end the world or humanity though, but they could wreck things, especially at civilization level. The flip side is massive cooling and the chain reaction to cause a snowball Earth, and this is harder to survive in many ways because a full snowball Earth is one with virtually no rain or place on land above freezing. You can retreat under the seas or underground, we have examined that option, even in scenarios where the sun goes out or Earth gets dragged into the interstellar void in our episode What If Earth Becomes a Rogue Planet, and you can see that episode for details on surviving that extreme scenario. However, if the planet's just iced over, your goal to personal survival isn't really a bunker for classic protection, but to help keep warm, and you ironically don't need a big farm to keep yourself alive, because what you actually want is greenhouse space. Small parcels covered in plastic or glass are going to stay warm and livable because Earth is still getting plenty of sunlight. This is a slow apocalypse, so there's lots of time to stage up manufacturing of plastics or glass, and the amusing bit is that even in an icy environment, but one still getting mostly normal sunshine, you could actually grow more food under domes than we currently do. Since water gets trapped under domes too, this same trick works for anything causing a drop-off in rainfall, and you can also turn seawater into fresh water by evaporating it under domes. In this regard, supervolcanoes are really the most dangerous plausible climate changer, as they can happen literally overnight, and the worst of the effect is right away, as the ash darkens the sky and chokes the land beneath under a blanket of cinders. See Brandon Sanderson's series Mistborn for a look at the sort of civilization and culture you might have afterwards, albeit a bit of a fantastic one. Eventually that ash converts into wonderful fertilizer and soil nutrient, but for a while, the sun is gone, and people are falling over from respiratory issues. The Volcano Explosivity Index, or VEI, goes from 1 to 8, with each increment 10 times stronger than the last. You get several VEI 5 and 6 events in any given century. A VEI 7 occurring in a given century wouldn't be particularly remarkable. The year without a summer of 1816 was caused by the last VEI 7, the eruption of Mount Tambora in Indonesia in April of 1815, which speaks to duration and severity, though also survivability. VEI 7 status, incidentally, requires a release of at least 100 cubic kilometers of material. VEI 6 would be 10 to 100 cubic kilometers, VEI 5 would be 1 to 10 cubic kilometers, and so on. It should be noted that at a global scale, the idea of being blanketed in ash is a bit of hyperbole. 1,000 cubic kilometers of volcanic eruption would take you to the edge of VEI 8, the last known occasion of that being Lake Toba 74,000 years ago, and the Yellowstone caldera eruption 600,000 years ago. And if all that landed in a circle 2,000 kilometers wide around that explosion, covering much of a large continent, it would only be about 8 centimeters or 3 inches deep. Spread over an entire planet, think millimeters. Those spread throughout an atmosphere, think months-long twilight. Incidentally, we have a few other mega eruptions that were probably VEI 8 more recently than Yellowstone, it's just hard to confirm their exact strength. The scale does not go up to VEI 9, as there is no confirmed occasions of 10,000 plus cubic kilometer eruptions, and the few possible candidates just barely scrape into that range on the upper margin. Probably they happen on other planets, but I don't think a strong case can be made for an eruption significantly stronger being possible on Earth, and thus I think we can say volcanoes don't really have a path to wiping humanity out, and they are definitely the sort of catastrophe the planet has a path of recovery from, though they could set off a Snowball Earth scenario with enough cooling. Ironically, they could also end a Snowball Earth scenario by covering the white, sun-reflective snow in black, sun-absorptive ash. Surviving this is mostly about keeping enough food to make it through a year and plant in the next, and we would expect harvests to be decreased rather than non-existent during the worst of it. To me, this is the sort of catastrophe that seems least likely to end existing civilizations, as it is a slow, rough grind where everyone has a lot of advance notice that it's going to be a hard year, and our technology makes us a lot more famine and crop failure resistant. So I would expect global efforts to dig in and endure, and that tends to be when stability is most handy, so I would not expect tons of separatist movements or revolutions. You could probably debate that historically. The probably volcanic winter of 536 AD began a very brutal period to live in, and is an example where you can get lots of secondary disasters rippling out from the first one. That bulk discount on calamities I mentioned in the intro, the plague of Justinian being one of those, and the first recorded plague pandemic. One catastrophe can weaken you for another unrelated one to kick you down, or even directly cause a second one. When it rains, it pours. We don't know if that calamity of 536 AD was a volcano, as we don't have a decent candidate available, and a comet has been suggested too, though it is hard to imagine that such a close pass by a comet wouldn't have been historically remarked upon. But it would have required an atypically large amount of sulfate for an eruption too, based on layers we can examine. For now, an interesting mystery, and a reminder that the buried dagger might come from unknown directions too. Speaking of plagues, BioWar is a scenario that definitely comes to mind, all the more so after COVID, and I remain optimistic that this will have ended up as our last true pandemic. We had a century since the last one, and our growing knowledge of medicine and science doubtless helped with that, and will only have grown in the aftermath of this most recent pandemic. Either way, there's no calamity right now that people better know how to survive, and I don't think many nations, even fairly morally grey ones, are really looking to develop bioweapons right now. If they did, survival techniques remain viable, lots of social distancing, sterilizing, and so on. Given that this one is pretty fresh in our memories, I think we can keep it abridged, but especially as technology improves, our options for quarantine, early detection, and sterilization to minimize spread will only grow, and thus probably minimize the disruption to our lives that would otherwise be going on. We generally don't expect intentional efforts to make bioweapons designed to wipe out humanity. Historically, militaries hate biowarfare as they tend to lose more troops to infections and plagues than swords and guns. So too, they tend to disproportionately hit the young and old, which means your gerontocratic leaders, which is the case in most cultures, would be authorizing research into something likely to kill them in particular, and painfully too. We are also not really in an era where people can do much research and experimentation in a vacuum. One lone lunatic is still very likely to get caught, and very unlikely to come up with anything major that will pose a real challenge to thousands of other sane scientists in that field. Nor is a major state really likely to want to invest a lot of time and research into it, in my opinion, for what that is worth. Which basically leaves accidents, though there are options like Grey Goo from BioWar-like nanotechnology run amok from an experiment gone terribly wrong. Zombie apocalypses tend to epitomize these sorts of accidents. Some effort at extending life or combating a possible plague or whatever results in people shambling around half-rotting and wanting to eat other people. I enjoy the zombie horror genre as next to the next person and don't really care about its realism much, but there are some pathways to options like this. Most presentations don't work. The zombies would be rapidly obliterated by all the gun-wielding citizens, and there are a lot more bullets than there are people. They are not hard to make, and all of that would be irrelevant anyway, as even a fairly badly equipped and trained military should simply blow through hundreds of times their number in classic shambling undead, barring unrealistic portrayals and plot contrivances common in such films. Your most likely scenario would be something more like a flubbed attempt at brainwashing, turning large chunks of the population into berserk, homicidal morons, and as usual, your goal is to hole up somewhere with food, thick walls, a radio, and lots of ammo, and wait till all the monsters starve to death, and all that's left over is their diminishing number, and the survivors who are very good at killing them or avoiding being killed by them. They might grab the occasional convert, but probably after that person took out several times their own number. A civilization arising after this from those survivors might be a bit brutal, but many earlier civilizations were, and for that matter Richard Matheson explores that very notion in his novel I Am Legend, the story that spawned the horror zombie genre, as well as what things might look like if that surviving and rebuilding civilization turned out to be the zombies, not the humans. When it comes to robots, this same approach holds for dumber examples of artificial intelligence, or myopic ones. It often seems it is a lot less likely we would be plowed under by a human-like artificial intelligence than by something more task-driven, paperclip maximizer style, where it is very easy to outthink it if you have some time or breathing room, or just walk around it. If some AI got unchained and crazy, whose main goal was just to repair roads, and it would blow up, attack, or pave over anything that got in the way of that effort, including cars trying to drive on those roads and thus damage them, then you would eventually find the holes in its monomania and survive inside them. It also raised the whole notion of if you can't beat them, join them, because in a lot of cases the reason why your zombies or mutant cannibals in the post-apocalyptic rad race aren't going to do well is that they are not attracting willing and skillful converts. The latter is more of a vampire-style thing, and that's because folks don't want to join them and don't like them. A lot of times, if some great new power is growing, it's got at least some appealing qualities compared to the alternative, and in the case of artificial intelligence of the more general type, that might be how they view humanity. As we discussed in other episodes, the notion of a snowballing technological singularity going from human intellect to godlike critter able to face off against all of humanity in a toe-to-toe fight, and from an evolution of days or even a few years, is really about as realistic as zombie hordes. More likely that AI is going to want to choose the more survivable path of friendship and cooperation, and while it is true that AI can be more alien than any alien, who shares with us a Darwinian origin and shaping, it is plausible that one that's focused on its own survival would be more human than alien, since it shares that Darwinian focus of self-survival and was raised around us, and probably read our philosophy and fiction too, not just our technical manuals. So we should not assume a power-hungry AI can just slip by hidden and undetected until it's in a position to take on and defeat the combined resources of humanity, especially a state of humanity which successfully created that machine to begin with and understands AI fully. See our episodes on machine rebellions and technological singularities for more discussion of that, and our episode After AI for more on what a world after a human-robot conflict might be like. Also something examined in Frank Herbert's classic Dune series. As to survival though, in brief, we shouldn't assume EMP weapons are particularly helpful against AI and robots, or that we can kill them Captain Cook style with logical paradoxes or our ultimate weapon of compassion, but we also shouldn't assume we somehow enter such a conflict at a disadvantage. Where an alien invasion would be concerned, that is absolutely not the case, at least for some centuries to come. The nature of the universe, where the speed of light is a limit on travel and communication, means you don't really expect to have massive galaxy-sprawling empires, and probably not much beyond loose alliances of goodwill, defense, trade, or federation between our nearest neighboring stars. This probably means it's just us versus one star system's forces, and probably only a fraction of those, not some galactic navy. However, anyone with the technology to reach us right now would win, period. Just from the energy advantage they would need to have to get here, assuming that our annihilation was their goal anyway, and your odds of victory in such a conflict are nearly hopeless, even before you include the likely odds that they are a K2 civilization, which, while only one star system in size, still effectively makes your classic space opera galactic empire of a million worlds look like some badly organized county trying to take on the combined open might of all of NATO. We've explored that more in our Fermi Paradox, Space Warfare, and Alien Civilization series though, and as we found there, the game changes a lot if they are not aiming to wipe us out, which we would know was the case if we were even aware they were invading, since the easiest ways to sterilize a planet are to send unmanned ships without troops on board to just ram into the planet rather than slowing down to conquer it, which would mean Space Command might get a radar blip a second or two before we all got atomized. So, if they are invading, it ironically is a good sign, and since time can erase the technological and tactical advantages they have, giving us a better chance of emerging alive and free from a protracted occupation, my advice would be to cheerfully seek terms of surrender, and I, for one, would welcome our new alien overlords. One upside about surviving the end of the world is that you probably have plenty of time to catch up on your reading, learning, and hobbies, unless your reading glasses break like happened to bookworm Henry Bemis in the classic Twilight Zone episode Time Enough at Last. In the meantime, for the rest of us, even though we know learning is a great long-term investment, it can be hard to balance learning new skills with everything else going on in life. But if you are not staying ahead by building new skills, you're falling behind, especially in the tech fields. That's why Brilliant builds its lessons for busy people with a bite-sized approach that breaks down important concepts into understandable parts. With Brilliant, you can start at any level and gradually master topics in as little as 15 minutes a day, anywhere, anytime, on phone, tablet, or computer, without spending years and a fortune on a degree. Brilliant is designed for high-velocity learning of math, science, and computer science, with guided learning paths to help you stay focused and reach your goals fast. With Brilliant, you can launch your own pace, learn on the go, and learn a little something new every day. To get started with a 30-day free trial, visit brilliant.org/IsaacArthur, or click on the link in the description, and the first 200 people will get 20% off Brilliant's annual premium subscription. So for anyone who missed the announcement on Thursday, I was recently asked to become the president of the National Space Society, and was very honored to accept. It's a chance to help promote space exploration and settlement, and one I'll discuss more along with the NSS as I settle in and hopefully live up to the honor. Needless to say, discussing space, our future in it, and how we'll get there are topics we're fond of here on SFIA, but next Thursday we'll be turning our eyes downward and to the past, as we look at the future of archaeology and some of the amazing technologies that will help us learn more about humanity's history. Then the week after that, we'll take a look at the concept of simulated universes and how we might hack or escape them if we're inside one. And 2 weeks from now, on Sunday, March 26th, we'll have our monthly livestream Q&A before closing out the month of March on March 30th with our 2-hour special, The Advanced Spaceship Drive Compendium, where we'll take a look at nearly 100 different star drives, from existing tech to the entirely hypothetical. If you'd like to get alerts when those and other episodes come out, make sure to hit the like, subscribe, and notification buttons. You can also help support the show on Patreon, and if you want to donate and help in other ways, you can see those options by visiting our website, isaacarthur.net. You can also catch all of SFIA's episodes early and ad-free on our streaming service, Nebula, at go.nebula.tv/isaacarthur. As always, thanks for watching, and have a great week.